So first of all, again, welcome to this program. We are going to discuss a little bit about the program itself, which of course many of you would like to know, the degree program that we offer and how it works. But then I will move on very quickly to something real, which means I will try to teach you some basics of machine learning first in a Google Sheet, where you will be able to see how numbers added and multiplied to make something learn automatically and why those equations are important. And then once we have seen those simple things in a Google Sheet, we will then move on to a Python notebook, and I will share with you all these files. So it's not that something which you will just see and go away. When I will start, I will share the links with you so that you can see on your own computer screen what is going on and you can practice if you want. This presentation which we are seeing right now, if you want to get access to this one, I'm going to share the link here in the chat window. Because this is the link to this very document that you are seeing on the screen. So we will start with a little bit about our data science program. Then I will introduce you to what is machine learning, why we call it a learning thing going on inside a machine. Then we will see a simple example in Google Sheet. Simple because Google Sheets are not meant to do extensive calculations. The modern trend with data is that you have so much of data, so much of knowledge that you can't handle it in a Google Sheet. So then you go on to better systems, and we will use Python programming. And then towards the end of this presentation, I will tell you what is the connection between what I have just told you and an LLM. So about the program, this is one program which is called the Data Science MPS, or the Master of Professional Studies. It is offered from two campuses, the main campus, which is in Catonsville, and it is also offered from the Shady Grove campus, which is where I sit. And I think many of you are interested more in this campus, although both campuses are open. There was a time when it was possible for students to transfer from one campus to the other. The size of the program has grown so much that we are now trying to convince students to decide before applying to the program which campus is better for them. It is possible at later on to transfer, but at least to begin with, go to one campus, because inter-campus transfers are becoming more and more difficult because of the size of the student population that applies and is selected. So you decide early on whether you want to go to this campus, the Shady Grove campus, which is where I am, or to the main campus. And you can explore the area. If you are from this area, you can explore these areas in terms of what they offer. They both have their own strengths and weaknesses. Shady Grove campus is a smaller campus compared to the main campus, of course, but being small means classes are more personalized, and we can provide better attention to students because we don't have that many students in a class generally. And that helps many students in learning very quickly, especially if they are coming from a background which is not very strong in data science or computer science. My email address is here, and the email address of the Shady Grove program is also there. I'm going to copy this also into the chat window for those who want to contact us later on. What is data science? You can find lots of definitions on the internet, but essentially it is a combination of various things. One part of it is computer science, where you need all the computer science knowledge and programming and the equations which are going behind the scene. To understand that part of computer science, you also need maths. And by maths here, we mean calculus and linear algebra. Both of these are needed. And you also need statistics. Why? Because this is data, lots of data, and you definitely would like to summarize the data, manipulate this data. So all the knowledge people have developed over a century of statistics is also needed. But one key ingredient which lots of people forget is the domain knowledge. So all of this data science can be applied to something, which means you can apply this to education, you can apply this to psychology, you can apply this to healthcare, which is my area of interest. I'm more in AI in healthcare. You can apply it to anywhere you like, but then you need the domain knowledge. And that's the very reason why we welcome students from backgrounds other than computer science to come into this program, because they bring their knowledge of their subject, which they have gained through a degree in biology, a degree in chemistry or something. But then they can bring that knowledge and then start using the data, which is now available freely on the internet. And more groups are putting this data free on the internet, can be used to do research, to understand problems, to solve big problems in healthcare, in finance, in all sorts of fields. So you see these three big circles, and then at the exact center, you see data science, which is a combination of all these things put together. So that's why when we give admissions, we take care of this thing that we want students not just from computer science or math or stats, but we also look at people with domain knowledge, because that's a big help. The program itself is primarily, we offer a Master's of Professional Studies, or MPS, which has 10 courses listed here. But if you want to take just first 4 courses and leave, you get a PBC, which is a post-baccalaureate certificate in data science. Some students start from this thing, which means if you think you are not committed right now, or you are not sure whether you should invest in an MPS degree, you can start with a PBC and say, okay, after 2-3 courses, you will get an idea of what exactly is going on, and maybe it suits you, and you say, okay, once I finish PBC, I want to move on to MPS, and in that case, all these courses count towards the MPS, and you go on taking more courses. Many students have done this thing in the past. Also, if you join for the MPS to begin with, but after 4 courses, you say, let me get this certificate, because then you can start looking for jobs in the area, and you think that PBC can help you getting a job, you can do that also. And if you want to get more information about these courses, their syllabi, of course, there's a website. You can search the UMBC website for data science. You will find all the information. So I will not go into what exactly is taught there. That's a long story, but keep in mind there are 10 courses. Out of this, first 7 that you see, 601 to 607, are called required courses. Everybody takes those courses. There is no choice. Once you have done those 7 courses, then you have electives also. And there are 3 electives you have to take. And you can take these electives from different pathways. One pathway is healthcare informatics. Another pathway is project management. Another pathway is policy making. You can use this knowledge also in all sorts of areas, including data science. And therefore, there are 13 different pathways possible. You can choose one pathway and say, I only want to study, let's say, healthcare. So I want to take courses in healthcare informatics only. You can do that. Or you can say, no, I'm not sure. All these subjects are interesting for me. So you can take one course, one elective in healthcare, the second elective in policymaking, third elective in project management, and that's also okay. So the electives are very flexible. They give you a chance to explore things or specialize if you want to specialize. As I said, in terms of backgrounds, people from all sorts of backgrounds come into this program. Computer science is there, but it is interesting to note that computer science is not the top field from which students come. Students come from other backgrounds. At Shady Grove campus, you will find students coming with a background in economics or policy making, biology, electrical engineering, education, psychology. You can name all sorts of things. What is important here is they all have some background in statistics. And people who study all these subjects, you can see, definitely go through some knowledge of some training in statistics. You also need knowledge of calculus and linear algebra. Linear algebra is needed because essentially everything that is happening here is a multiplication of matrices. And that's the realm of linear algebra. You also need calculus. And you need programming. Now, not everybody who applies has taken courses in this area. So, for example, somebody who has done a degree in biology may not have taken courses in calculus and linear algebra, or may have taken courses a long time ago and says, I have no memory of that course. I hated that course. Now I can't do anything. In that case, it is possible to show that you know the subject very well through some other informal coursework you did. Maybe you can go to a community college and take a course. There are online courses offered all the time which you can take. And therefore, it depends on you how you want to cover. But definitely, if you are coming into a data science program, you need those things. So it's not just a requirement as such. This is the bread and butter of your life. From here onwards, if you go into data science, you will be dealing with numbers, and you will be summarizing them. You will be doing calculus with them, more programming with them. So these 3 things are needed. Based on the first column, you can come from any of these and many other fields, but then you need these 3 backgrounds to apply for admissions, because when we give admissions, we definitely look for this background. Okay, so that was my long story about the program itself. We don't want to go too much into this thing because that's the knowledge that you can get from internet by searching UMBC website. I'm more interested in telling you something about machine learning itself and what we can do in the 35-40 minutes that we have available. So the first thing is, when you talk about learning and machine learning, the first question is, what is learning? So learning, and this is the information taken from internet, is the process of acquiring new understanding knowledge, behaviors, skills, values, attitudes, and preferences. So people who do this thing, everybody, all of us actually learn something throughout our life, starting from taking the first step to doing most advanced maths and physics. We are learning these things, and through this process, not only that we are learning knowledge, we are also developing behaviors and skills which are difficult to write, but we gain them with time. With experience, we win those skills. That's called learning part of it. And this learning becomes intelligence if you also have the ability to apply this knowledge to new situations. So a person who can solve lots of complicated problems is considered intelligent, because not only that he has all the knowledge or she has all the knowledge, they can also apply this knowledge to real situations and solve problems which nobody else in the past has solved. So that's called intelligence. There are three main types of learning or machine learning too, and these are shown here, and you can see at the top written supervised learning, unsupervised learning, and reinforcement learning. And let me explain each one of them separately. What is supervised learning? Supervised learning, as the name implies, is the learning when you supervise each and every move. So for example, the photograph here shows a father teaching the kids something. Let's say the father is teaching a Russian language. If you are teaching a language to a person, you tell the child that this word is pronounced exactly this way. You can't mispronounce. The person who is teaching you the language will keep telling you, no, that's not how you pronounce it. Say it this way. And they keep repeating until you get the word correctly. That kind of learning where each and everything is controlled and given is called supervised learning. Compared to this, in the center is called unsupervised learning. And unsupervised learning, a good example which I have shown here, is called a cluster-based learning, where think of kids, very young kids, you give them a box full of blocks, and these blocks are of different shapes, can be cubes, can be spheres, can be pyramids, and can be of different colors. You give this whole box of, let's say, 100 blocks to children and say, play with them and see if you can find a pattern. And you must have seen it yourself when you were a child. And if you have brothers, sisters around you who are this age, you will see, ultimately they come up with this conclusion that, yeah, there are different colors here. So colors, for example, is the first thing children find out, and they start separating out these blocks into different colors. Once that is done, they realize that, yes, they are all red, but they don't look identical. Some of them are spherical, some of them are square, some of them are pyramid. They don't even know the names of these shapes. So they may not be calling it a pyramid or cube. They just know that there are shapes which are different from each other, and they will further divide this box of 100 shapes into smaller groups. That thinking which is going on in their mind is called cluster-based learning. So you are trying to create clusters, but nobody is telling you to do it. This is your general common sense which you are using to find out patterns in the data. A large number of research going on these days is this type of learning, because we don't know exactly what we are looking for. What we are looking for are patterns in the data. So if you think of the Amazon, for example, Amazon, if you start working as a data scientist with Amazon, they will most probably ask you to do this type of research and find out which kind of customers are more important for us, and what should we sell to different types of people who connect to us. So students are buying more books, but they are buying books only in the beginning of the semester. During the semester, what exactly are they buying? If they are living in dorms, probably they are buying things which are needed in the dorm. And those patterns you can discover by looking at data. They don't know, you don't know, but you can discover those patterns by using very well-defined techniques in machine learning, which allow you to see those clusters. If you can see them, you can find them, you can tell this to the company, and then they can make money out of it. They can provide better services also to people, because then you don't have to search for the information that you need. You log into Amazon. In January, you buy books. February, it automatically starts showing you things which you need now in your class. Maybe you need more notebooks. Maybe you need to upgrade your laptop or something. That information can be shown to you. So that kind of learning is unsupervised. And the third category, which is on the other extreme, is called reinforcement learning. And reinforcement learning is used more often in the field of robotics. And this is a kind of learning which sometimes can be tricky and dangerous. Essentially, what you see here is you want a certain behavior at the end of the day. You're not monitoring what exactly the robot is doing step by step. You only say, at the end of the day, I want this to be completed. Think of this again as a child to whom the father or mother says, I want an A grade in your exams. period. I'm not offering you tutoring services. I'm not helping you in the home to learn the material. I'm not your teacher. I'm not doing anything with you. The only thing I demand is an A grade in the exam. Well, if you do this thing, the problem is, what if the child starts cheating or copying things? Because the only thing you are insisting is the final grade. The final grade should be A. I don't care how you get it. If you want to cheat, go cheat. I'm not even checking you. So reinforcement learning is a very complicated branch of learning. It is generally not used in data science. It is used more in robotics, and there is a lot of research going on seeing how to control this thing, how to make systems which learn and learn because you are giving them a feedback. So it's not completely unsupervised learning. You are giving some supervision, but their supervision is limited compared to a normal supervision. So you are supervising only after 1 day, after 5 days, after one semester. You are only checking the output, not on a daily basis. And that's something in between supervised and unsupervised learning. Okay. If you think of this in terms of mathematical models, when scientists talk about it, when data scientists talk about it, they say, I need a mathematical model of my data. A mathematical model from the point of view of a data scientist is nothing but an equation. So in our minds, we are thinking of an equation. So for example, this data that I have written here under the supervised learning heading is age and wealth. If I plot them, I see these dots. This is the data plotted. And then on these dots, I have tried to fit an equation, a straight line, which is the best line that describes all of this data. It doesn't touch all the points, but touches most of them. And it is somewhere in between these points when it cannot fit exactly. And that equation in this case, for example, is written as y is equal to 3x plus 6.5. That's my model. So when I say mathematical model, I mean that equation. Can I extract that equation? And yes, there are very well-defined techniques in statistics and machine learning to find out which equation describes my data. Because the moment I have the equation, I can do all sorts of interesting things. I can predict things ahead of time. In the middle one, when you see these circles drawn, they are called clusters. And knowing these boundaries of these clusters, that this cluster has this center and a circle of this much radius around it, that's my model. So the middle one actually has three equations there. Three circle equations, which I know. If I know them, I essentially can describe the data. So whenever you'll hear the word mathematical model, that's what we mean. Okay, so that's how things were going. But a long time ago, around early 60s, somebody thought of understanding human brain and see, okay, computers are limited. There were computers at that time, but computers are limited in terms of what we could do at that time. So they started thinking of human brain and see if we can copy or replicate human brain. A human brain is a combination of billions of neurons, the one shown here, neurons, and electrical signals go through this system. So you see a network of billions of these neurons connected to each other and tiny electrical signals passing through this thing. And they said, okay, this is a very simple system in which signals are coming in, something happens in the nucleus, and the signals go out. So they tried to replicate this thing in a more structured way. In the right-hand side diagram, you see three inputs and the neuron, which is the equivalent of a neuron in the human brain, and then an output comes out. Now the output, if you think of this as electrical signals, if there are signals are coming in, they are definitely merging in some way and then going out. So the output essentially is the sum of inputs, but it can be a weighted sum of the inputs. And we will see in a minute what weighted means. So it can be a weighted sum of all these inputs. So these three inputs are coming in. You are taking this, and this, adding them. But not just adding them, you are multiplying them with some number also. So let's see what that means. So we are trying to understand a neuron, which will take us to neural networks, and then we'll do something with it. So this is the same diagram, this one. Let's say I have these three inputs. One of them is 1. The second one is 2. The third one is 3. So their numerical values are 1, 2, 3. The output I'm seeing is 13. And I say, oh, 13? How do I get 13 out of 1, 2, and 3? Now, I cannot add 1 plus 2 plus 3 to get 13. That's not possible. So what I can do, and this is one option possibility, is I take the first one, 1, multiplied by 3. So you see here, I'm multiplying it by 3. Then second one, I'm multiplying by 2. And the third one also, I am multiplying by 2. So this 3, 2, 2 are three weights, 1, W1, W2, W3. And therefore, by doing this study, I have somehow, because you still don't know how I found out that this number should be this, but I have found out there's three numbers, three weights are there, W1, W2, W3, and I know their values also, 3, 2, and 2. Okay, now you can say, is that the only solution? No, there are other solutions also possible. Maybe you can do something else with this thing. Maybe you can add 5 times 2 plus input 3. That will also give you 13. This is one solution. So always when you go into this type of computing, which we call soft computing, answers can come out by doing various combinations of inputs. This is one combination which is giving you this answer. It's still very simple maths, simple multiplication, although in concepts, this may be the first time you are seeing it, but if you look at the maths, it is nothing but multiplication and addition. And I'm trying to get an output from this thing. But the idea here is to understand weights means you don't want the full input. You want to take the input and multiply it by some number and then get the output. So that multiplication that you are doing is called the weight. Okay. Let's see this thing in a Google Sheet. And this link I'm going to share with you in the chat window. And I will also switch to that file, which is this one. So now that you have it, do you have access to this file now, everybody? Okay. So now that you have this thing, you can see, and you can see on my screen also, that we are going to do something. So we are going to play a game. There are two human beings with funny names, X1 and X2, and they are trying to decide if they want to go to a restaurant. They will not go to a restaurant if no one says yes, which makes sense. If there are two friends and nobody wants to go to a restaurant, why will they go? But if one of them says, the other one says, okay, then I will go. So one of them saying yes, the other one saying no, they will still go. The same situation, which I have just described, can be written in a tabular form, and you see X1 is one person, X2 is the other person. Both of them are saying no, then they are not going to the restaurant. One of them saying no, but the other is yes, they will go to a restaurant. Or the first one is saying yes, the second one is no, they still go to restaurant. And if they both say yes, obviously they go to restaurant. So we come up with this structure. All the four possibilities which are there between these two people are now listed in this table. I can simplify this table to look more scientific by replacing no with a 0 and yes with a 1. And what you see on the right hand side is this table, this one. It is exactly the same thing, but it says 0, 0, which means no, no is no, no, yes, yes, no, both are 1, and yes, yes is also 1. This structure that you have just seen is also called in electrical engineering an OR gate. And computer science also, it is called OR gate. We are going to focus on this thing. And what we want to do is we want a system to learn how to reproduce this thing without knowing the logic. So the logic is not known. We only give the system this information. That X1 is saying this, X2 is saying this thing. Can you tell us what will be the output? What will be the result? So the result of the game is not known to the person, not known to the machine learning algorithm, but the system will learn, and let's see how it learns. Here comes a little bit of maths. As I said in the previous diagram when we were seeing there, that we are multiplying inputs X1 and X2. So now we go back to this one. Let's go back and show you. So here you have three inputs, 1, 2, and 3. The one that I'm showing you is even simpler, has only two inputs, 1 and 2, X1 and X2. And I'm saying the output will be X1 multiplied by its own weight, X2 also multiplied by its own weight. That will be Z. But then the problem is, if you just do this thing, the number may come out to be a big number, maybe a small number, but you only want 0 and 1. So you say, okay, I will take one more step, and that is the output actually will be 1 if Z, the sum comes out to be greater than 0.5. And if it is less than 0.5, I take it as 0. So again, the output will be 0 and 1. That's the advantage of doing this thing. We want to clip everything to 0 or 1. There is one more thing here, which I'm not going to discuss in detail right now, but let's see what it does. It is essentially called a parameter which allows you to learn quickly. If you make this number very big, let's say 1, the system may not learn because it will jump so quickly from one place to the other that it will miss the point. It will not be able to learn. If you make it very small, like 0.0001, it will take a long time to learn. 0.2 is more or less the number that is good enough for us. And for most applications, it is 0.2. So let's right now keep it fixed at 2. I will define one more thing, and this is D that is coming out. This is the difference. D here stands for difference between the output which is there, the Y, and the Z that I will calculate. Between this, actually this should be Y prime. Z and Y prime. Okay, so those were equations, but the problem is you will still say, but what about weights? You are still not telling me about weights, and what should I do? So that's here comes the real intelligent part, which somebody thought of and said, okay, I don't care. I can start with any value of W1 and W2 randomly. I can choose any value of W1 and W2, but then my system will learn with time, and the learning equation is written here. And learning equation says, whichever value you have taken, the initial value, add to this quantity, which is what? Which is alpha, which is a number, 0.2 fixed. The difference between the value that you wanted to get and then this output and the value that you are actually getting by calculations. That's D. And X is this input. So when it is 1, it is 1 here. When it is 2, you take this 2 value, this one here. Okay. So some maths, new for you if you have not seen it, but not difficult. There is no calculus yet. Or at least you can't see where the calculus is here, although there is some calculus here, but you can't see. For you, this is a pure algebraic equation, simple equations written, but let's see what we can achieve with this thing. And what we achieve with this thing is interesting. Now, this is the table that you had. This is this table, reproduced here. And I've reproduced it 2 times, and you will see why. What I do here, I say this 0.4, I choose which value I want. Or right now I'm choosing 0.4. When you get this file and you want to experiment, you can change this number, but let's for now say I have no idea what this is. Let's say 0.4, and W2 I say can be 0.3, 0.5, but let's make it 0.4 right now and see what happens. Okay, remember this Z is supposed to be W1 times this one, X1, and W2 times X2. If you click here and you click here, you will see this is the equation written. E22 is this number, 0.4. B22 is this number, which is 0. F22 is again 0.4, and C22 is again 0, which means both are multiplied by 0, and the answer will turn out to be 0. And yes, it is turning out to be 0. Okay. Then comes the condition. And the condition here is, remember, the condition here was that if this number is greater than 0.5, I will call it 1. And if it is not, it is 0.5 or smaller, I will call it 0. Since it is less than 0, less than 0.5, you can see the system calculates it as 0. And finally, we need the difference. Difference between what? Between this value, which I had, this one in this column, this one, and this value which I have just calculated. They both are the same, and therefore the difference is 0. And if the difference is 0 from this equation, if this quantity is 0, the original weights and new weights remain the same. The equation is there. You can see the equation there. 0.2 is there. D is this one, I22, and B22 is X1. Second one, this one, looks the same, but now it is talking about X2. So this is rather than this one, this is now taking C22. The 0.2, this 0.2, remember, is the value that we are giving to this parameter. So I calculate this thing. So when I start creating this file, it is an empty file. The only numbers I write are these 2 numbers. That's why they are in this color. I should have given that red color. Probably it is better. But this is the starting point. Using these, I calculate new values. And you can see nothing changed, which means the numbers remain the same. Okay. But we want to reproduce the whole table. There are 4 rows here. This is only 1 row. So what I do, if you look at the color, yellow color here means this number is copied from there. So it actually says, if you see J22, it is coming from there, copied here, and this one is copied. If you click here, copies from there. K22, this number is copied here, which means whatever the last values were, now I use those values, although those values have not changed. I repeat the same calculation as before, and I will not repeat again, but essentially you are doing the same kind of calculation as before. W1 times x1 plus W2 times x2. You calculate this thing. This again is less than 0.5, so the output is 0. The difference now is 1. You wanted a 1 here. You wanted a 1 here. You are getting a 0. That's not good. That's not what we wanted. And therefore, when that happens, you know that something is going to change. And yes, weights change. So now this 0.4 is now 0.6. System has learned that something is not correct here because I'm not getting the correct answer. Since I'm not getting the correct answer, let me update the weight slightly. So it did an update to the weight by 0.2 and said, okay, rather than 0.4, let's try 0.6. Again, this number is copied here. This number is copied here. I don't know whether you can see my mouse moving, but this is the number which I have copied from here. And I do the same calculation. The difference turns out to be 1, which means something is wrong. 1 means difference should be 0 actually, which means my prediction should be the same as the value that you wanted, but it is not. When it is not, I have to change. And you can see this number now changed from 0.4 to 0.6. Now they both are 0.6. So we started with 0.4, we reached at 0.6 one more time, and we get again 0.6, 0.6. That's very good. The problem is now if I ask you which number is correct for W1, you will say it can be 0.4 and 0.6. What about W2? It can be 0.4 and 0.6. That's not good. We want all these numbers to be the same, which means W1 should never change, W2 should never change. So that first iteration is over, but we have learned something. The system has learned something by going through this one iteration, but it has not reached a point when it can be said that confidently that yes, the system has definitely learned. So we go on repeating. This whole table that you see here is copied here again. Again, the numbers copied from here to here, here to here. You do all these calculations and you see 0.6, 0.6, 0.6, 0.6. These numbers now no longer change, which means you have found the solution. You have found two weights, only two weights that can reproduce this whole table of 4 values. Not a big saving, you can say, because if you want to memorize this table, you can memorize by memorizing 2 more numbers. But at least you have summarized the knowledge of this OR gate into 2 numbers only. And if you want to reproduce this table, these 2 numbers are enough to reproduce that thing. Okay, that's very good. We have learned something. So now you can see what learning means in the world of computers and data science by doing simple calculations, which I agree, when you will go back and you will have to spend a bit more time in understanding each and every step again and again. But the equations, as you can see, are not complicated equations. They are simple multiplication, division type of things which are needed. Okay. At this point, let's take one more jump and say, okay, 0, 0, 1 was there. What if I write them as colors? Which means 0 is 0, which means it has no color. And as the number grows to a bigger number, it becomes white. So when it is 1, it is white. And when it is 0, it is black. Once you reach this point, you can say, so that means we are going closer to images, because images also, gray images also have 2 colors. So when you can see this thing as in terms of colors, you can say, something is interesting here, because what we just learned can be applied to maybe images also. And yes, you're right. So let's go back to my PowerPoint, this one. We have seen this sheet. Now look at this one. In this example, I'm going to do, and this is something which I'm going to do in Google Colab, and I will give you the link in a minute. But here we are trying to see if we can make a machine learn to recognize handwritten characters. This is handwriting recognition. The handwritten characters written by lots of people. There are, I think, 2,000 something samples like this, and there are lots of numbers. If you look at this detail, for example, this third number here, 08, and this number is probably 8, but terrible handwriting. Probably is a medical doctor wrote this thing, because I can't even see whether this is 8 or 7. Very poorly written. But it is handwritten character, and of course, when people write by hand, they can write in any way they want. You can find, for example, somewhere you will find a 7 written as this 7, and sometimes people write 7 with a line in between, which is also 7. What you want now, and that's the target, you want a system to learn to understand a human written language. a much bigger step compared to what we were doing in Excel. Here it was nothing but a tiny gate. Now you are getting ambitious and you say, I want to do more and I want to go into, sorry, somehow captioning started for me automatically and I don't know why, but that's good. I was seeing who's talking to me. Okay, so this link I'm going to share with you. This is this link. Now remember, whenever you get this link, you will see the file, but you will not be able to change those files. Why? Because those they are my files. I don't want you to change them, but you can always make a copy of this file and play with it. So I would recommend that whenever you get time, make a copy of it. Right now you don't need a copy because I will be telling you how to use it. But when you get time and you want to really make your hands dirty by doing real calculations, make a copy and then play with it. What we want to do now, and I have provided more links for you so that if you want to go back and see something, you can find out. But what we want is we want a system to learn to recognize these characters, which means I will write by hand something on a paper, give it to my system and say, tell me whether this is 1, 2, 3, 4, what have I written? And I want to see whether the system has learned to understand human written language or no. Okay, so let's go back to this file, which is here. Whenever you do programming in any language, Python included, you also have to tell the language which libraries or knowledge you want to be imported into this file. So this is a Google Colab file. A Google Colab is something which anybody who has a Gmail account also has access to Google Colab. So you only write Google Colab in your Google search engine, and this page will open up and you will have your photographs appearing on the right hand side because all of us have Google Colab, although we may not be using it. So this is the Google Colab file, and I'm saying this is meant to be used as a programming tool in Python. That's what I'm going to do. So the first block, you see 4 lines. I'm saying sklearn. Sklearn is a very powerful library for machine learning. If you want to go into data science, you should know about it. You should have heard about it. And I'm saying from the sklearn library, it has lots of data sets already inside it. I am saying load the data, which is digits. Oh, sorry. Which is the load data is called digits, which means with digits, these digits. And I'm asking it to load that data, which means all these images will come into my program. Just like numbers can be in Excel file or Google Sheet, I'm saying bring all of them into my computer. Okay. And then there are some other things. I'm also saying I want to create a machine learning model, which is a perceptron. Perceptron is exactly what you did in Google Sheet. It is only that now this one is much more powerful. But it is the same, conceptually, it is the same thing. It takes inputs, multiplies them with something, gives you the output. And then there are 2 more libraries which I need to plot and do things. But this is the block which is not doing something intelligent. It is only asking the system to bring that knowledge into Python. Okay. Once I have done this thing, so I execute this thing. And when you see, whenever a block like this has this run symbol or play symbol, that means there's something to run. This one has no such thing. Here, there is no such thing. Here it is. So this one I just executed. It took 0 seconds, which means it took hardly any time to run. Then I say, okay, now load this data. So it has loaded the data of digits into 2 variables, X and Y. We will see what they are. The first question is, how many symbols are there? Which means if you count these, this one is a small sample. How many in total there are? And the system is telling you that I have just loaded 1,797 samples into my file, into my computer. Okay, that's good enough. Very good. That's a lot of data. I want to see what it is because, okay, it is this thing, that many, but what is there? I want to see. I enjoy seeing things. So I run this thing and I say, I take one random number because there are 1797. I say, let's say 547 and show me what exactly it is. And it gives me very hopeless result. It says 547 is these numbers. And I say, well, okay, those numbers don't tell me much. I was hoping to see an image of some kind. If you count these numbers, you will see that there are 64 of them. If you count them, all of them, you will count them, there are 64. And that gives you a hint, aha, so that's something like 8 by 8 thing. So what I will do, I will also see that this is X. So give me a minute. Let me go back. This is X. This is the input, X. Y, when you see Y, that is the output. That is the result that you want to get. Here you are getting the same thing. X is this thing, although you don't understand it, but okay, it is X. I also want to see what is Y. And Y tells me that it is actually number 9 written here, although I can't see where it is 9. So what I do, since I know now that this is an 8 by 8 type of matrix, I say, okay, reshape it and show me what it is. And I see this matrix. If you see this matrix from a distance, you will see it has some resemblance to 9 because all of this is 0. All of this is 0. And these are big numbers, 13, 15, 12. This is a blob. And then if going down is also big numbers. So this is some kind of 9, but not really 9. I want to see how it looks like. This is not needed, but let's do a map of this thing. And I am plotting the same thing, which is there, but now I'm plotting this quantity. Rather than plotting them as a matrix, I'm saying plot that as an image. So I'm showing an image. And now if you see it from a distance, you will see that this is actually 9 written. Very ugly 9, but it is a 9. Okay. So now you are happy that, okay, you have loaded numbers here. They are all images of 8 by 8 size. They are all the numbers written, which you just saw here. And you want to play with this thing. Okay, so you say, okay, let me create a model, perceptron model here, just as we did in Google Sheet. What you do, you say CLF here stands for a classification model. Why? Because you are saying all these images are in 10 classes. Either they are 0, or this is 1 written, or this is 2 written, or this is 3 written. There are total 10 classes. So that's why classification model. CLF here is just a name. You can change it to UMBC, it doesn't matter. But what it says is that this is the perceptron model that I want to create. I create this model. It takes hardly a second, and you see a number 93, which means your machine learning model has learned how to understand these written characters up to a 93% accuracy that quickly. You can improve this thing, but even as these 3 lines of code is enough to create a model which understands these human written characters 93%, which means if you give it 100 of these characters, it will probably understand 93 of them correctly. In 7 of them, he will make mistake, but that makes sense because if you look at this data, as I said, this 8, for example, is a very ugly one. This 2 is not a very clean 2. This 1 seems to be crying and has drops coming out. So there is always some problem. Even human beings can't understand all of them. Sometimes we confuse, and especially if we are younger kids, we will have difficulty understanding some of these numbers. And our model is saying that I can tell you 93% of the time that this is correct. Okay. But then you can ask a few things. You can say, okay, but when we were doing this thing in Google Sheet here, you were talking about weights. And we came up with 2 weights at the end. How many weights are there? Because this is a big task. This is an image, 8 by 8 image, and not one image. 1700 images there. So you ask the system, okay, tell me how many weights you have, and it tells you, you run it. It tells you that I have 650 weights total. And you can see the speed at which it happens in Python, because Python is much faster. It is a more efficient system. It immediately calculates and tells you 650 numbers required to reproduce all of these images 93% of the time. As I said, with these type of things, you are never 100% accurate. You are accurate only a certain percent, and 93% is a very good number, and you can improve this thing. Now the interesting thing comes here. You must have heard of ChatGPT a lot. And you must have heard that ChatGPT also has weights or parameters. ChatGPT has 100 trillion parameters or weights. This model that you just created has 650, and the model that you had there had only 2. So going from 2 to 650 to this doesn't take much time. Right now we are at 650, and we will see how to go beyond this thing. We still have a few minutes, so let me finish this thing. And if you want to see what happened there, because the problem is, you are seeing that 93% accuracy is there, but I want to see what happened behind the scene. Where are those images now? And what is the prediction? So I want to do this thing, and I run this code, which is slightly more difficult to understand. So I will not go into the details of this thing, but essentially you are saying, pick images, a few of them, and show me how they look like. And I can see, so it asked me how many images you want to see. I said, show me 3 of them. And it showed me this image, which was there in the data set, and said the prediction which means the machine learning model that you just created predicts that this is 9. And the actual number given to us by the person who wrote this number, he said that this is 9. And my model is also saying this is 9, which means I'm correct. Second one, 7. The prediction is that it is 7. The actual model also said 7. And I think this one also probably will be, 7 and 7. So now you can see that if you look at these images, unless you go very far from the screen, you will see that these images are not very clean. They are supposed to be very tiny, like this size. That's the reason why you are seeing them as blurry, because you have enhanced them too much. You have enlarged the size too much. And if you want to see one example, for example, where this number and this number don't match, remember, out of every 100, 93 will be correct. Only 7 will be wrong. So if you want to see something wrong here, you probably will have to go to a bigger number here, maybe make 3 to 30 and see all those images. 30. See all those images, and then you will find some examples where the machine learning model made a mistake. But this block itself is not doing anything. The only thing it is doing is it is showing you the results. So the real intelligence, the real machine learning happen only in these 3 lines. And that's fascinating. If you look at the amount of knowledge you have compressed is so much, 2000 handwritten characters, which means now you can write any number you want on a piece of paper, scan it, give it to my program, and the program will detect that this is this number, and the code behind the scene is only this much. That's the only code that you needed. Okay, and we are all, toward the end of the session. So I told you about this ChatGPT. If you want to experiment with the large language models themselves, there is actually a last block here where you import a model, and I'm not going to run it. But this code, you can see, is also very small. And you import a llama model with 13 billion weights in it. 13 billion weights are here. You can import this model, run it. Let me see if I need to run it. If I run it, it works. So it is asking me for a token. So this is one thing which you will learn when you will go into large language models, that everybody needs a secret code from the company with which you are working. And that code looks like something like this. I have written star and I've changed this thing, but this number, I have it. And where is my number? Let me try to find out my number. Well, okay, I forgot to copy the code here. But in any case, when you run it, it will ask you for your. So what you need to do at this point, you need to open an account here. And I want to point out that when you open an account, it gives you the feeling that you have to pay, but you don't have to pay. So it says set up billing. Do not set up billing. Don't give them your credit card number, because that can cost you a lot. In the beginning, it is free. And what I'm doing is I'm using only the free version. I have not given my credit card number to this company. So I'm using the free version, but you can try this thing. And the beauty here is you can do this type of work in OpenAI, in ChatGPT. You can do this thing in Gemini, but that's a user interface given by them. You want to play with this thing inside Python. You want to bring this whole model into Python and play with it. That's how you do it. So your prompt actually is this thing. This is what you can ask Gemini directly also. But here the advantage is you decide which model you want to run, and you are running this model. If you want to change this model, you can go to their website and say, no, I don't want Llama 3. I want Llama 77 or some other model, and use that one. And this is your prompt. This is when you try to set up the LLM correctly. And then you ask the prompt. The prompt comes out. When you run this thing, you will see the answer. And essentially, it explains to you what exactly is a large language model. But you can change this to anything you want. As long as you have the token taken from this website, you can do it. So let's go back and see. We started with something very simple. We started learning with a simple neuron, which has only 3 weights. Then we experimented with this system, which has only 2 weights. Then we went to perceptron model here, and we learned human language, how to understand human written characters, and we reached a 93% accuracy here. And this system had 650 weights. And then from there onwards, you can have 13 billion weights also imported here, already calculated by someone. Now you can reproduce human language by knowing those weights. So those weights are now available to you to generate human language out of it. So that's a very fast tour of machine learning, going from something very simple to something advanced. I hope you learned something, and since you have links to all these files, you can always go back and experiment. I have left comments inside those files. I have also given links to YouTube videos and other things where you can go and learn more things. Uh, Still, if you have questions, you have my email address. Any questions at this point? We still have 5 minutes at least, maybe more.
There's a question in chat. What projects are you currently working on related to AI in healthcare?
Yeah, and I saw, give me a minute. Let me,
Oh,
well,
sure.
actually, Chris is here. Chris can type the email address because I don't have it in my memory. My memory is not good. So,
Take care of it.
as I said, my area of interest is healthcare, uh, AI in healthcare, and I take up projects which are in this area. There are two different kinds of things we are doing right now. One of them is related to Alzheimer's. And I have some students who are coming from NIH who are working on a project, on different projects, 5 different projects, all related to healthcare. They are taking actually a course called Data 606, which is capstone projects. And this is a collaborative work because they have an expert on Alzheimer's at NIH who is also a supervisor who actually knows more about this thing than I know. I am providing the support from the AI side, what exactly the AI can do there. So that's one thing. I also have another student who is presenting actually this weekend a paper at Johns Hopkins University. This is the research he has done in terms of predicting the survival rate of people who come to the hospital with certain kinds of disease and seeing based on what happens to them in the hospital and the number of times they come to the hospital, what is the chance of their survival over a long period of time. A kind of relationship between the care they get and the output, the results in terms of their survival. So that was a good paper. It was accepted there. And I can also give you one more thing while you are here, is my own website where you can find more about my projects. But that does not mean if you look at my page also, you will find out that this is not the only thing I do because of the age that I have. I have spent so much time in industry and in academia that I have students working on projects, even on stock market projects, which at a personal level, I don't like. It's a very complicated market and it's very difficult to do something. But there are students who have worked on stock market predictions. There are students who have used this knowledge for environmental data analysis and social good also. So there is a student who is working on data from Baltimore City about people who have mental issues and they call different centers for help. And that data has been recorded by police, by many other departments, and she's trying to collect them to create a predictive model to say what will happen if the first phone call says this thing, which way things are going, what should we do with this kind of data. So, but mostly my interest remains in healthcare. But students, when they work, this is more from my point of view, this is more an application of machine learning. The subject knowledge you bring with you. And that's what I was trying to say earlier, that you don't have to have a degree in computer science to become a data scientist. If you are a biologist, I'll be very happy to see a biologist or an economist, because then you bring the knowledge which I don't have. And you will not have the knowledge that I have, but we can work together on projects where this knowledge can be combined and we can create wonderful solutions for industry.
Looks like that's it, Dr. Youssef.
Okay, we are just on time. 7 p.m. we were supposed to end. Thank you for coming. I hope you will keep learning. You may not come back to UMBC for a degree, but I hope that you will keep learning data science because this is useful. This is becoming the future of mankind. It is everywhere. Data is everywhere, and these models are everywhere. You will need them in real life someday. And therefore, I hope you will continue the journey itself, even if you don't get the time or funding to get a degree, because that also has limitations. How much time you have to get a degree, how much money you have to pay for it. We do have funding, and if you write to the SG program, we do have scholarships available, and that can be a big help. The cost, generally, we try to reduce the cost by using different methods, but scholarships are there. Write to us, and we will try to connect you with the right people so that you can see which options you have to finance your education.
And I just want to reiterate again, both Chris and myself, as Dr. Youssef have noted, are easily accessible through the email that Chris has kindly placed in chat. Please don't hesitate to reach out. One of the benefits of applying to data science, specifically at UMBC, at the universities at Shady Grove, are additional financial aid and scholarship opportunities, right? So We are both happy to walk you through some of those opportunities. Again, if you are interested in exploring or completing a UMBC degree, we can help you with those next steps, so don't hesitate to reach out. And we hope you have a wonderful rest of the evening. Thank you so much for joining us.